Welcome to our EECS 2210 project, the home thermostat. Next.
The introduction. So the core components of the systems includes the temperature sensor, which is called the DHT11, acts as a thermometer providing real-time temperature readings. And we have MOSFET, referred to as the series 2N7002, serves as a crucial electronic switch, enabling or disabling the fan based on the temperature thresholds, and diode, referred to as IN4148, ensures protection by preventing reverse current, safeguarding the motor during operation. Next slide.
So how it works, right? So we have our threshold temperature set to 24 degrees Celsius. Once the sensor detects a temperature above or equal to 24, the MOSFET activates the fan to cool down the system. Once your temperature drops below 24, the MOSFET switches off the fan, saving energy. The data is then sent to the server, updating it in real time using a one-way or two-way communication, where we're getting and receiving data. And what we have also added a green, red, and white LED light to represent whether the motor is on or off, and when it is shut off manually. Green represents on and red represents off, and the white one represents the emergency button. As you can see, this is just a screenshot of how our website server looks, and more will be explained later on in the demonstration.
Okay, so for the demo, this is our project. We have a ESP32 here, a 9-volt battery, which is connected to a breadboard supply board, which changes the 9-volt battery to a 3.3 volt, which is connected to this rail over here. We have our fan, which is connected to a DC motor. The positive is connected over here, which is connected to a diode. And then the negative of the DC motor is connected to our MOSFET, the 2N7002 MOSFET. The negative of the DC motor is connected to the drain of the MOSFET. The gate of the MOSFET over here, this wire is connected back to the ESP32. And then over here, the source of the MOSFET is connected to ground. And on this side, we have a 3.3 volts from our ESP32 and the ground from our ESP32. They're two different rails, but we have a common ground across them. Over here, we have the white LED, the green LED, and the red LED that we talked about. We also have a 1K ohm resistor across all of them. So the short leg is connected to ground and the long leg is connected to the resistor, which is also connected to our ESP32 board. Over here, we have our temperature sensor, which is connected to the ground, the positive 3.3 volts, and a signal wire connected to our ESP board. And over here, we have our Arduino IDE code. And on the serial monitor, it shows the temperature values and the humidity sensor or humidity percentage. And then over here, we have our web server with the air conditioning system, the temperature. It gets the values in real time, and also the humidity and the fan status is off or on. And then we also have two buttons which we can turn off basically the motor manually, and the white line comes on, and then we can turn it back on as well. And then now if I heat it up by blowing on it, you can see it turns on, and then our fan also turns on, which you can see it is also decreasing the temperature as well. And also the humidity is very high because I was blowing on it, and it will keep cooling it down until we reach below 24 degrees, which will turn the fan off, and turn the red LED on. Now to show you the turn off button, let me heat it back up again. So it turns back on over here. And then if I turn it off and then press system disabled, you can see it turns it off completely. And then if I turn it back on again, it will keep turning. Thank you for listening to our demo.
The MOSFET here acts as like an electronic switch in the system. It controls the flow of the current. When temperature reaches or exceeds 24, it's turned on. Once temperature drops below 24, it turns off. The precise control here allows the MOSFET to make an efficient choice for switching high current devices. The purpose of the diode in our circuit is to use to protect the circuit, mainly the MOSFET, from any damage. The motor turns off. Its coil generates like a reverse current, so due to the collapsing magnetic field. The diode positioned parallel to the motor that acts as a flyback diode to safely redirect this reverse current, preventing it from damaging the MOSFET or any other sensitive components in the circuit. Moving on.
As you can see from the schematic right here, so we have an SP32 board, and from slide 3, we refer to as this the LED red light, green, and emergency, and we have a 9 volt battery here as it's connected to the breadboard, and then we have another external source right here at the end of here, and all the information that's being put through the DHT11 temperature sensor, it will be redirected to the SP32 board, which will eventually be sent to the server. Next slide.
Let's move on to some challenges we faced while building this project. The first challenge we came across was finding the right MOSFET that we should use for this project. The first MOSFET we initially used was the ALD 1101 dual N-channel MOSFET we were provided within the lab during the duration of this course. However, that MOSFET was not compatible with this project because it only provided a logic level of 3.3 volts, which was not enough to turn on the motor since it only received 0.06 volts. Therefore, we used the 2N7002 MOSFET, which was more compatible with this project. Another challenge we came across was hosting the web server on the ESP32. Next slide.
All right, so for voltage values for this specific N MOSFET, it has a threshold voltage of 2.1 volts typically. And when the MOSFET is off, we have a VGS of 0 volts, a VDS of 3.29 volts. And of course, there's going to be 0 voltage across the motor. And VGS is less than the threshold voltage, so the MOSFET is off. And when the MOSFET is on, when the temperature goes above 24 degrees, we have a VGS of 3.25 and a VDS 0.24 volts. And the voltage across the motor is 3.04 volts. So the VGS minus the VTH is bigger than VDS. So the MOSFET is on and is in the triode region, meaning the MOSFET can be used as a switch. Next, please. Thank you for listening to our project.